Okay guys, welcome back. This is Abdi Mahamanur. I'll be taking for you volume scale factor, which is abbreviated or contracted as VSF. It's a mathematical concept which is found in the book of Form 2, and it's very much examinable, as you know that. If you want to prove it, write that statement. You can go to the likes of Med Familia, to the likes of Spotlight Form 1 and Form 2. You can also go to and see and check from the KLB. I will be trying my best to help you in solving questions that comes from this subtopic, which is volume scale factor. Remember, volume scale factor is gotten as VSF is gotten as linear scale factor cubic. Linear scale factor cubic. Now, if volume scale factor is gotten as linear scale factor cubic, now let's see an example from this. Let's see the first example. This example 1. You're told a football chip in the form of a sphere is inflated so that its radius increases in the ratio of 4 to 3 full stop. Find the ratio in which the volume increase. Now, when I want to solve a question of this kind, if a ratio is given, that's the linear scale factor. So we are going to say like this: linear scale factor is equal to 4 to 3, or 4 out of 3 in fraction form. Now we know that volume scale factor is equal to linear scale factor cubic, which can be written as 4 out of 3 cubed then. 4 cubic is what? 64. 3 cubic is 27. So ratio will be 64 to 27. That is the ratio of their volume. Let me go ahead and see example 2. Without wasting time, let's go ahead. We have example 2. Now you're told the ratio of the length of the corresponding sides of two similar rectangular water tank. Is 3:5. Full stop. You're told the volume of the smaller tank is 8.1 meter cubic. Calculate the volume of the larger tank. Calculate the volume of the larger tank. Now, when you read this question, you're told the ratio of the length of the corresponding sides of two similar rectangular water tanks is 3:5. The volume of the smaller tank is 8.1 meter cubic, or cubic meter, you can say. Calculate the volume of the larger tank. Here, solution. I have the linear scale factor, which is 3:5. Can be written as or 3/5. 3/5. Then let me get the volume scale factor. Is equal to linear scale factor in bracket cubic, which is 3/5 cubic. It will give me 27/125. 3 cubic means 3 times 3 times 3, which is 27. 5 cubic means 5 times 5 times 5, which is 125. Now, let's use similarity. Using similarity, you can say, using similarity, you can say, volume of larger tank, volume of larger tank divided by, it is volume scale factor is equal to volume of smaller tank divided by, it is volume scale factor. We don't have the volume of the larger tank, so we are going to say y all over, which y represents what? The volume of the larger tank. It is volume scale factor is 125. Is equal to 8.1, which is the volume of the smaller tank, divided by its volume scale factor, which is 27. Then you can cross multiply. Then by cross multiplying, you have 27y is equal to 125 times 8.1. Then to get the value of y divided here, 27. Here also 27. Cancel. Then y is equal to, by 27, 1 by 27, 0.3. So we can say y is equal to 125 times 0.3, which is therefore you can say volume of larger tank is equal to that 7.5 meter cubic. That's 7.5 meter cubic. Then let's proceed ahead and see more examples so you understand better. Let's proceed ahead and see more examples. Let's see this one. You're told the volumes of two, example 3, this example 3, the volumes of two similar solids cylinders are 4752 centimeter cubic and 1408 centimeter cubic. Full stop. If the area of the curved surface if the area of the curved surface of the smaller cylinder is 352 centimeter squared, comma, find the area of the curved surface. Find the area of the curved surface of the larger cylinder. Of the larger cylinder. Now remember, we are given the volume of the two cylinders and the surface area of the smaller cylinder. Now, how are we going to solve this question? Because we want to get the surface area of the larger cylinder. Let's go to the question and understand the nature of the question first. We are told the volumes of two similar solid cylinders are 4752 centimeter cubic and 1408 centimeter cubic, full stop. If the area of the curved surface of the smaller cylinder is 352 centimeter squared, comma, find the area of the curved surface of the larger cylinder. Remember, back in primary, we said CSA, which is curved surface area, is gotten as 2 pi RH. But here, that formula cannot work, my friends. Remember, the moment you have volume, we are talking about volume scale factor. Remember the time you hear volume scale factor, we are talking about the volume of the cylinders. Remember the time we are talking about curved surface area, we are talking about area scale factor also. So now, let me go to the solution part. Volume of the ratio of their volumes. Let's say like this: ratio of the volumes. That is 4752 divided by 1408. So we can divide this one. We can simplify this one by using common factors. 4752. Yeah, it is 4752. So this number is divisible to 11. By 11, the number, it will give us 4, 3, 2. By 11, 1 goes there. 2, 8. 1, 2, 8. Then let's say by 2, 64. By 2 is 2, 1, 6. So this is what I'm having. I can still simplify this thing. Okay? Can still simplify this one. But let's go ahead and say like this. You can even say by 6 is that 6. This one is not divisible to 6. Let's say, remember we have 216 here. So let's say the ratio will be 216 divided by 64. Now this is the simplified ratio of the two volumes. Yeah, can I still say that? So, if we go ahead, we know that volume scale factor is equal to linear scale factor cubic. Let's get the linear scale factor first. Because for us to talk about area scale factor, we must know the linear scale factor. So that we get the area scale factor then. Now, to get, this is the formula which says volume scale factor is equal to linear scale factor cubic. But if volume scale factor is gotten as linear scale factor cubic, how can we get the linear scale factor then? So we're going to say cube root here. Here also cube root. Cancel these two. Then we know that linear scale factor is equal to the cube root of what? Volume scale factor. So I'll say the linear scale factor is equal to the cube root of this one, which is 216 over 64. Now let's try to get two numbers. Of each one of them, when we multiply by itself 3 times will give us 216. I hope you can say linear scale factor is equal to the cube root of 6 power 3 over 4 power 3, because 4 times 4 is 16 times 4 is 64. Then by 3 1 by 3 1. Again by 3 1 by 3 1. So I will have the linear scale factor will be 6 out of 4. 6 out of what? 6 out of 4. How is this one helpful then? Because we have, remember we have the area scale factor, the area scale factor of the smaller cylinder, which is 352. Let me get the area scale factor now. Area scale factor is equal to linear scale factor square. So our area scale factor therefore is equal to 6 out of 4 squared. It will give you what? That's 6 out of 16. So from there you are told, look here, if the area of the curved surface of the smaller cylinder is 352 centimeters squared, find the area of the curved surface of the larger cylinder. So we can say if 16 is equal to 352 centimeters squared, what about that 6? That's the question mark. Say cross multiply. That 6 times 352 divided by 16. By, let's say, by 4, 9, by 4, 1, by 4, 8, because of that 2, then we'll have 88. We have what? 88. Then we can say that will give us what? 88 times what? 9, which will give us 2, then 72, 79. So this will be the final answer for your information. So this is the application part, because you have the volume and the area, then you are told to get the area of the other cylinder, and this is how you're going to solve such kind of questions. Please make sure you subscribe this YouTube channel, academic channel. It will help you. It's going to help you. It is very, very useful compared to any other YouTube that's existing currently in Kenya, because this is an academic tube which will help you if you're doing KCSE or KCBE. Remember, we are also trying to bring so many classes of primary mathematics that will help you in KCBE if you are now in primary. Please, if you have comments or if you have something to supplement, make sure you leave your comment in the comment box. Otherwise, I wish you the best.